Right, so in this series of short videos, we're going to look at how to solve a pretty complex sequence. Okay, so we're looking at an electropneumatic sequence. That's what we've got here, and we're basically looking to control this with a PLC, and it's a sequential task. So it does, all this sequence first, and this, and then it loops back around, and it goes through the whole lot. And there's a number of steps there's a number of components we've got to control, but it's sequential. Okay, and we want to look at how we can make our ladder logic sequential so that we can solve this problem and how we go about that. Okay, so that's kind of the big thing that we're going to look at. We're going to look through these videos. We're going to look at the design process. We're going to look at how to code it, how to kind of break it down nice and easy. It is a difficult task, so there's some complexity obviously in this, but we'll try and keep it as easy as possible, and look at how we can get some simulation, get some visualizations on it, and how you can test it out without having to actually have the electropneumatic circuit set up. Okay, so all just through the software. So this is the task, and as you see, if you're not too familiar with how the sequence works, there's going to be something that's going to turn on, something's going to move forward. That's what the plus means. So as if this is cylinder A goes forward, then cylinder B will go forward, then cylinder B will come back, then cylinder A will come back. And we see this number 2 and this kind of bracket, so it means this group will happen twice. So we go A plus, B minus, A plus, B minus, A minus, and then it'll go on to the next step. Okay, so you've got a time delay in here as well. We also have just 2 cylinders moving in and out at the same time. So in this part of the sequence, you'll see it go A plus and B plus will move forward together, then they'll move back together, and then we'll repeat it twice. This will move forward together, then move back together. Okay, so that's what the sequence means. So as I said, it's quite long. That's what some of the symbols mean. And if you haven't really kind of spotted it, you'll see that we're kind of breaking it into sections. So this is kind of our first sequence, then there's a bit of a pause, we do another loop, then there's a bit of a pause, then we do another loop. Okay, and then it finishes off. So there's kind of 3 sequences. So what do I do? What is the first step when I'm looking at a task like this? Well, what I do is I write it out fully. Okay, so this is actually shortened down because you see that we've got the ×2 here. To represent this happening twice. So what I actually do is I fully write it out. So if you see, if we move down to here, D plus, C plus, then we have A plus, B minus, A minus, and then I've wrote that out again to represent this to C minus 1 second. And what I've done is I've grouped them into the three sort of sequences that's happening, and you can see the last one is quite a long one. Excuse me. So that's what I've done. I've wrote it out, and I've wrote it out in its full steps. Now, just if I go back up here, some of these things happen twice. Okay, so as I said, I fully write them out. Okay, now if it was happening 3, maybe 4 times, maybe 5 times, I would look at an alternative method to solve this. But just because it's written out twice, I'll keep it as simple as we can, even though it's a complicated circuit. Keep it as simple as we can, and we'll just look at this approach for a moment. Okay, so I've read out all my steps. These are literally every single step that I have. Then what I'm going to do is I'm going to give them a number. Okay, so a step number, so that I can keep track and I can actually fault find it if I do something wrong towards the end. So I'll write these in red. And what I do is I start at 10, okay, because my resting state is going to be 0, okay. So we do step 10, then step 20, then step 30, step 40. And you might be asking me, why am I going up in steps of 10, okay? And this is just a kind of habit that we get in. It's a good habit for coders to get in, because what we do is, if we just had 1, 2, 3, 4, if I missed a step by accident, I had to include a step, I would have to shift or increment all my numbers down further. But if I have a gap of 10 in between them, well, if I did need to put in another step in here, I could just label it number 11. Okay, so it's just a kind of handy sort of approach that we do for this. Okay, so like I said, I'm going to label out all my steps. Okay, and I'm just putting them here in red for you. Hopefully I haven't skipped anything. So what I'll do is just pause this and type them all in. Okay, so when you've labeled all the steps here, right, so I've got 38 steps that I've got to complete in this sequence, and then it loops back around. So it's quite a long sequence. But again, you can see that, well, if I get stuck at any particular point, I can look back and see what's supposed to happen. So I write out a nice table of how my sequence should work and which step numbers am I expecting each action to happen at. Okay, so at step 10, I want D to go plus, and at step 100, I want A to go minus. So that's the first kind of analysis into it. Then what we got to do is we got to figure out, well, what components are we using, because that's going to have an impact on our code. Okay, so I'll scroll down and I'll show you the circuit diagram. Okay, I'll zoom out just a wee bit and then I'll zoom back in. So you'll see this is the circuit diagram. So we can see really that D and C are just lights. So D plus just means the light going on, and then D minus means the light going off. Here, when we have cylinders, A plus means A going forward, and then A minus means it coming back. Okay, and then you'll see the sort of inputs that we have. So we've just got a start button. We've got sensors for each of the positions for our cylinders, and then we've got the outputs to drive those. Now, just notice that for A, it's a spring returned direction control valve, so that's going to have an impact on our coding, how we code that. Again, we've got both outputs here to trigger forward and backwards of our cylinder B. So again, that's going to be slightly different coding to this, so that's a good thing to note. Obviously, we've already said that these are just LEDs. So we've no sensors now to monitor these like we have down below here. So again, we'll keep that in mind. And then what you'll just notice is, this is more for when you're actually going to hardwire it yourself. I'm actually activating relays, which then go and activate the two outputs. Okay, so I'm indirectly operating the direction control valve through relays from the PLC. So the PLC operates the relays, which then operate the solenoids on the direction control valve. Okay, so that's just a protective measure in place. So that's if you were going to actually build the system, this is how you would go about it. Okay, this is actually the wiring diagram for it with your PLC. Okay, but it is just good to know that we have spring return here, and we don't have spring return in here, and then that these are two lights. So we start to understand our sequence a little bit more. Okay, so now we're going to jump into Codices, into the code. We've got most of our setting up done. So once we've done that, we'll move into the code now and get it set up.